I've been thinking about that that fun with categories talk. That was brilliant. I haven't dared look at Idris yet, but I mean the source code. But I was thinking about Wildberger's surfaces video and the oleoid and ruled surfaces. And about the modulus of the Chinese remainder theorem and what kinds of ruled surfaces you get. With different modulus and different groups. If you sat down and said, "No, I'm going to make a mathematical theorem about this," you'd have a lot of work cut out. But if you programmed it, and you had some kind of way to, in the manner that Kvetkovich did experiments with graphs. I'm just trying to motivate the teaching research connection. People criticize Wildberger, but just because he says things like, I think we should change the way we teach maths, and everyone immediately thinks that means throwing away every syllabi in every university. It just isn't like that. You can do these things gradually. You can do them as extra exercises. You don't need to chuck all your stuff away. But you do need to create an atmosphere where people have a kind of healthy attitude towards their concretions. Some of this stuff is not really worth that much. Take the ideas, keep the ideas, but keep the medicine, don't keep the disease. If you want to create a theory of groups and surfaces and topology and singularities, and you just sat down, in a few hours of programming time you could explore some of these spaces. So and yeah, There's some really good stuff that you could do. Even without things like Tilt 5 AR headsets and things, but that must be amazing what they... It's gone so quiet, I don't know what they're doing, but... There's still a lot you could do with just ordinary displays and ordinary computers. And you don't need churches, and you don't need sex, and you don't need freak shows. You just need a mind. Why everything has to be... It's disgusting. So the video I wanted to show is Mathologer doing these connect the dots on circles. If you think of two circles, if you connect the subsequent dots on each directly above, two circles in parallel planes, say you've got the z-axis up, x across, and y into and out of the frame, and the two circles are connected with parallel lines, you get a cylinder. And if you connect them opposite, you get two cones with a singularity at the point of halfway between on the radial axis. And there's probably a connection with group representation theory. And I have the feeling that if you have a mechanical model underneath this, which is a program, but you don't have to go and develop your own special package and choose some concrete language to put it into, because this is the kind of thing you want to be able to do. I'm only giving one example. I'm not starting a program to develop a new field of mathematics and a whole set of subfields and a journal and conferences. I'm just trying to say what it is you need to, the kind of infrastructure you need to do good research. You need the tools to be able to connect these ideas, and then so you've got all these specialisms that you need to connect, and you need a connecting matrix that is not going to create a new specialism, a new field of abstract geometric algebraic number theory. You want a culture which values teaching as much as research, and which recognizes that there are these connections between fields, and shows the students the connections, and gives them the tools to explore the connections. It's more about the connections. It's more about the contextual translation of these ideas than it is about the things that they supposedly represent. And also a lot of the so-called pedagogical issues that they're not really to do with teaching at all. They're to do with turning students into little automata that can solve a certain class of problems that professors are happy cooking up year after year after year when they submit exam questions. Things like notation, and there are these arbitrary choices that are made that well, actually you can explore things like that with category theory, but sometimes you need to be able to see both points of view. They're two different ways of writing the rules of an inner product space, of axiomatizing inner product spaces, and they're both equivalent in the sense that there's a one-to-one mapping between the two. But when you're drilling students to be able to solve the problems, and you ask them to switch to the notation where, I don't know what it is, where distributivity works with right multiplication, not left multiplication. It's something like that. And if you're drilling students to solve problems, they've got to learn one, and because you're turning your student into a little algebraic manipulation machine. It's pretty difficult you can't really expect this machine to be able to adapt very quickly when you switch from one notation to another. And my song, the song I was thinking of today, was Nick Cave and the Bad Seeds song called The Carney. So that's my weather report.